Hello students and parents, welcome to our next lesson. This will be lesson 4.4. Renaming fractions is the overall title, but we're going to be doing a lot with fractions, both in this lesson as well as in the next two to close out chapter 4. So it's really important that we get these concepts down. I know for many of you, as we went through this in class, you guys were like, we've done this before, this isn't hard, but the reason why it's really important is, as we've talked about in the fundamentals of math, it is very foundational. So this is setting the foundation for fractions, because guess what? Next chapter, we are going to be doing operations with fractions, which means we're going to be adding, subtracting, multiplying, dividing, doing a lot of very fun and cool things, but we need to understand how fractions work in order to get there. And you'll see as we go, a lot of this is building on to what we've already been going over. So first thing to know within this equivalent fractions, it just means fractions that represent the same value. So if I were to say 5/15, it's the same value as saying 1/3. 6/12 is the same as 1/2. 18/24 is the same as 3/4. So these are the same. But let's get to lowest terms. Out of these, this is the lowest term, 1/2 is the lowest term, 3/4 is the lowest terms. So we want to simplify them to get to the lowest terms, which means we can't reduce them any further. So when we get to 1/3, we're like, okay, that's it. There's no more I can do to this. 3/4, you're like, oh, it's bigger than 1/2 and 1/3, like the numbers. But no, we can't do anything. We can't divide anything evenly into both of these. So we're done. That is the lowest term. So our steps for this, we want to find a number that divides evenly into both the numerator and the denominator. So numerator is the top, denominator is the bottom. And I have in the right here, we want to remember our divisibility rules. So that was at the very start of this chapter. So I've got our past videos in the description if you need to review those. But the reason why divisibility is so important is because it helps us figure these out. And then you just keep on simplifying until the fraction is in its lowest terms. So in this one, 5/15, if we divide it by 5, so 5 can go into 5 as well as 15, because the divisibility rules, if it ends in 5, then 5 can go into it. 5 and 0 means 5 will be divisible by it. So divide it by 5 means we want to put 5/5, and this is telling us we need to do it for both the top and the bottom. So 5 divided by 5 is 1. 15 divided by 5 is 3. Another way to think of it is, what times 5 equals 15? 3. That might be a bit easier, depending. But that's essentially what we're doing, is we're dividing by that. All right, we've simplified this to 1/3. It's in its lowest terms and cannot be simplified any further. Same with this one. From at the top, we see 6/12. 2 can go into both of those. So we say, all right, 6 divided by 2 is 3. 12 divided by 2 is 6. But then we have to ask ourselves, every time we do this, have we simplified it fully? Like, can this get any lower? That's what I have here. Is 3/6 in its lowest terms? The answer, no, it's not. So we're not actually done here. It means that we could have pulled a bigger number than just 2. I could have said, oh, actually, 6 goes into both of these. And that would have gotten me to this much faster. But I'm showing this because that's okay. If you do a small number and you're like, uh-oh, it can still be reduced, you just keep on going. That's what this rule up here. You just keep on simplifying until it's in its lowest terms. As you get going, though, you'll see that you get better at this as you go. So we need to continue simplifying. 3 can go into both of these, so that gets us to 1/2. So 1/2 is our answer, as the fraction 6/12 is now in its lowest terms. So our turn here of doing this, 6/8, you say what can go into both of those? I know 2 can, so let me try 2 and 2, and this is divided by. That will get me 3/4. Can it go any smaller than that? No, so that one is good. 12 and 18, let's see. I know 6 can go into 12. Can 6 go into 18? Yeah, it can. So let's divide by 6 and see what we get. And this is the showing your work part, is I'm not just pulling 3/4 and putting it there. I'm showing, okay, I can do 12 divided by 6, and that will equal 2, over 18 divided by 6 is 3. So that gets me 2/3. Yep, that looks right. And let's check the work. Is 2 times 6, 12? Yes. Is 3 times 6, 18? Yes, it is. We'll do this last one here, 20 and 25. I think of 5 being my first one. Why? Because the divisibility rules tells me if it ends in a 0 or a 5, 5 should go into it. And I know 2 would go into 20, but 2 cannot go into 25 because look, divisibility rules tells us that if it doesn't end even, it won't go into it. So let's try 5. So we're doing 20 divided by 5, which equals 4, and 25 divided by 5, which equals 5. So that's 4/5. So that is as small as I can go for that. On the next page, you'll see practice problems. And as I've talked about many times in math classes, we just need to practice. Practice, practice, practice. So this would consist of you going through what we just did on that side. And then if you have questions, what does put it in their lowest terms mean? Go back to the section right before, and this gives you the steps. So 4 over 10, 2 could go into both of those. What do I get? 2/5. Great. How about this one? 10/15. I know that 5 could go into both of those because of the divisibility rules. Hopefully you see, I'm trying to use the right terms to show you. Like the divisibility rules that we started with can be so helpful for this to really help you get these numbers down a lot faster or quicker. And we'll do this one. This is a bigger number, so it might be a little bit tricky. But let me think. I know 9 times 9 goes into 81. That's my first thought. It's like, okay, 9 times 9. 9, can that go into 63? Let's see. I think the divisibility rules say that if we add these two numbers and 9 can go into it, then it works. 6 plus 3 is 9. Can 9 go into 9? Yes, it's 1. So that tells me I should be able to divide by 9. I already know the bottom will be 9, and then 63 divided by 9 will be 7. Or I could say, what times 9 equals 63, and that should be 7/9. So that's what we're wanting to do. For this one, divisibility rules, what happens when we see a 5 and a 0? 5 would likely be a good choice to think of this. So that's what this is doing. Simplify it to their lowest terms. You'll have homework problems at the back of this packet. And when it says simplify them to the lowest terms, we're just wanting to know, okay, this can get smaller. This can be simplified. How do we do that? We find a number that can divide evenly, and we just keep on going until we can go no further. So 7 and 9, they cannot go any further. That's as far as they can go. But 8 and 20, those are both even numbers, so I know at least 2 could go into both of those. But guess what? I think 4 could also go into it because I know 2 times 4 is 8 and 4 times 5 is 20. So for this one, I would put 4 and then work that out and then see what you get. And then these would be your answers. But I would like to see the work shown just so I know you understand what we're doing. And then maybe if you get it incorrect, I can say, oh, you subtracted. If you did 10 minus 5 and you got 5/3 or 5/10, if you did that, then I would say, okay, I can write a note, oh, we need to divide. So henceforth, we need to put the division symbol there. All right, that's for the first one. Next, let's get to the cancellation method. Okay, for cancellation method, this is bringing in prime factorization, which we've already gone over and have already learned. But if you need help and a review on that, go back and watch some of the previous videos of this chapter and we'll go over it. But this is using the tree or ladder method to find the numbers. So our first step is find the prime factorization for both of the numbers. So I have 36 and 60. Then I need to cancel the common pairs of factors. So this is what we talked about, and I'll do it up here in a second. Then we need to simplify the remaining numbers, and then just double check that it is in its lowest terms. So for 36 here, if we were to do that, then I would say, okay, 36, let's do the tree. So we have 6 and 6. What times what? 2 times 3 equals 6. 2 times 3. So that's why I would put a 2 and a 2, 3 and a 3. For 60, I'll do the tree method as well, just because it makes it a little less writing. So we have 2 times 3 equals 6, and 2 times 5 equals 10. 6 times 10 equals 60. So I double checked my work. That should be correct. Let's move the 2 and the 2 down here, and then the 3 here, and then the 5. Next step, cancel out the common pairs. So I want to cross off if they match up. So if there's one at the top and one at the bottom, we can cross them off together. They might not be lined up. That's okay, as long as you have a matching pair, one at the top and one at the bottom. This then leaves this, so we simplify it to 3/5. And then I need to double check, is this in its lowest term? Yes, it is. So I'll do this example here. So let's start with 18. I'll do this one in the ladder method. So 2 can go into that. 9, 3, 3, 3, and 1. And then I can ask myself, is 2 times 3 is 6 times 3, 18? Yes, it is. So for 18, let's put this here. So we'll go 2 times 3 times 3. Now how about 24? I'll do the tree for that one. I know 6 times 4 is 24, which is 2 times 3 and 2 times 2. So I have 3 2s and 1 3. So I have 2, 2, 2, and 3. Now, step 2, cancel the common pairs of the factors. There's a 2 and there's a 2. There's no more 2s. So that means I need to leave these ones. But how about 3s? Yes, there's a 3 and there's a 3. So I'm left with 3 over 2 times 2. And then you just simplify. Part of simplifying is doing the math there. So that gets me 3 out of 4. So that's my answer. So I would like to see work like this as you're going through each of them. But I'll go ahead and flip to this side. These are the practice problems for doing this. And the reason we're doing this is because I want you to really understand and get these down so that you can do it very confidently as we go. So let's do 36 over 48. So we have 36. I know that is 6 times 6. That means 2, 3, 2, and 3. So let me write this down here. We have 2 times 2 times 3 times 3. I can double check that by going 2 times 2 is 4, times 3 is 12, times 3 is 36. So yes. And then let's do 48. I know that is 4 times 12. So that would get me 2 and 2, 4 and 3, 2 and 2. So wow, a lot more for this one. But I need to make sure I'm getting the 2's here, the 2's and the 3. So that's 4 2's, 1, 2, 3, 4, and 1, 3. Step 2, cancel out the common pairs. So there's a 2 and a 2, a 2 and a 2, no more 2's, but there's a 3 and a 3. So this actually comes out to the same as we just did, 3 over 4, because I want to do 2 times 2 to get me here. Let's try this one, because I think this one will probably be different. So we'll do 27. I know 3 can go into that, which will get me 9, 3, all right, so 3 cubed should be 27. So I'll put 3 times 3 times 3. And then how about for 45? For that one, I'll do the tree, because I know that's 9 times 5. That would be 3 times 3. 5 can't go any smaller, so I have 3 times 3 times 5. And let's cancel out for our next step. So that would get me 3/5. So that is my answer for that one. And then you can just keep going throughout it. But if it's saying cancellation method, this is what we are looking to have. I should see trees, I should see ladders, I should see crossing things off, because this shows me you understand what we're doing, because in the next section, we're going to have 2 fractions with different denominators, and then we're going to bring in the least common multiple. The least common denominator is what it's called, but it's finding the least common multiple to get them to match, and it's just going to build from here. So it's really good if you can show your work and really understand that this is an important part of what we're doing. But next, let's get to improper fractions. So improper fractions are steps to turn a mixed number, such as 3 3/4, into an improper fraction, 15 over 4. You want to start at your denominator, which is 4, going in a clockwise direction, which is this way. You first multiply, so 4 times 3, and then you add the numerator, 3. So it's 4 times 3 plus 3. And that's what it shows right here. So that is the equation we get if we want to move the number. What I had us do in class, and for you all here, is let's draw this out, because this is actually, I think it makes it really fun for you that are artistic, or that this really helps, is we're drawing this direction because that is clockwise, And then we're saying first we multiply and then we add. This one too. First we multiply and then we add. One more, we're going clockwise direction, we multiply and then we add. So then if I do this down here, this is me saying we have 3 times 5 plus 2. This one is saying 6 times 2 plus 7. This next one is 9 times 4 plus 5. And the last one here is 8 times 7 plus 1. So then we just have to do it. This gets me 15 plus 2 equals 17. And then we keep it with the same denominator. So that would get me 17 over, look right here, over 3. This one, 6 times 2 is 12 plus 7 equals 19. And we have that over 6. Right here, 4 times 9 is 36 plus 5 should be 41 over, keep the same denominator, 9. And this one, 8 times 7 is 56 plus 1 equals 57 over, keep the same denominator, which would be 8. So 57 over 8. And the improper fraction, as we talked about, is usually it is very top heavy. So this will be too much on the top and very small on the bottom. And when we see this, because next we're going to learn, let's take an improper fraction and get it into a mixed number. But what you need to know for this, I would just draw this arrow on everything as we're doing that. So as we get to the practice problems, which will be, the homework is filling all this out, because the more you practice, the more you will learn it. But I would just, anytime I get this, draw this. So that's telling me 2 times 1. Do you have 2 times 1 plus 1? So that's 2 plus 1 is 3 over 2. There's my answer there. For this one, we're going clockwise. We're multiplying. Then we are adding. So we have 5 times 6 plus 5. I know that's 30 plus 5 equals 35. So this would be 35 over 6. Right down here, we're going clockwise, multiply, then we add. So we have 8 times 8 plus 3. 8 times 8 is 64 plus 3 equals 67. So that gets us 67 over 8. And I'm using the same denominator. So that's something you want to make sure matches up. In each of these, if there's a 2 here, I should have a 2 in my final answer. But I think these are so much fun. So I hope you have fun doing these as well, because maybe it's the drawing part of it, maybe because it's like rules that we just need to follow each time. And if you follow these rules, and see, this is order of operations. We learned that last chapter. We do the parentheses, we do the multiplication first, going left to right, and then we add. So 35 plus 3 is 38. That gets me 38 over 5. All right, let's move to the opposite of this, converting to a mixed number. So now they are going to give us the improper fraction, and they're going to say, turn it into a mixed number. So our steps for this is we want to divide the numerator, that's the top, by the denominator. An easy way to remember this, and this is what I've talked about it so much in class, and I'm not sure if people just think it's cheesy, but it helps me so much. And I know some people still get a little confused. So please remember this. The number on top, just think, the number on top is afraid of heights. They want to get down off of being up so high and get safe inside the house. What is the house? My computer had a little trouble with that, but this is the house. So if I see 19 over 5, I say, oh no, I'm scared. I want to get safe inside of the house, which is here, which is long division. That's all the same. We need to do long division. Right here, do the long division, and then what you see will be the mixed number. The 5, which was already in the denominator, stays there. So same thing as what we're doing up here. You keep the denominator the same. The 3 that we get from this, that's the number found on top of the house, and I'll do this down here as well. And then 4 was the remainder in the problem, which becomes the numerator. So if we do this right here, we have 19 over 5, and we're told, let's put this into a mixed number. 19 is afraid, wants to be safe inside of the house, so let's put number 19 in there. 5 on the outside, then 5 can go into there. How many times? If I did 2, that would be 10, so it can be higher. 3 would be 15, 4 would be 20, so that's too big. So let's go with 3. 5 times 3 is 15, and we get remainder 4. We don't want to keep going because we're not doing decimals as we go. But we have 3 numbers now. We have a 3, we have a 5, and we have a 4. Easiest way, go back to what is the denominator given to you. Put that there. All right, first thing to know. All right, what is our big number? The big number will be right up here, so that would be 3. And our remainder will always be the numerator. So let's do this for 7 over 2. I tell myself 7 is afraid of heights. Please get me safe inside of the house. And let's see, I know 3 can go into that, would get me 6. Remainder 1. So I look at this, what is the denominator? The denominator is 2, so let me make sure it's there. Then I know the remainder is always the numerator, so then what's left is the big number. And then, guess what I can do to check my work? And this is something on assessments and even homework I would suggest. Let's do this method and see, does it work? Is 2 times 3, so 2 times 3 plus 1. That would be 6 plus 1 equals 7, 7 over 2. These are equal, yes. So 3.5 is the answer. All right, the practice problems with this. So this is telling us convert these improper fractions into mixed numbers, show your work. The work we're seeing is the division that you're doing. So I have it here. I say 22 is scared, wants to be safe inside the house. So it goes in the house. Let's do the long division. 6 times 4 is 24, so that is too big. But how about 6 times 3? That will get me 18.